Hello everyone and welcome to my channel Aptitude Club. Today in this video we are going to take up a very good question on LCM and HCF from numbers section. And this question has two challenges. One is there is a rule that we must know if we are solving questions on HCF and LCM. Very frequently we have seen questions being asked from that rule. Quite simple rule, and I'll explain that. And the second is the application process. Now we can know all the theorems and all different formulas and techniques, but beyond that there is something called as a problem solving approach, and that is something which is very open ended. Now it takes a lot of experience in solving to be able to think that okay, maybe this can be used in this question, or something else can be used in some other question. So that pattern of thinking develops with a lot of practice. So that's the reason I took up this question. Again, as usual, I'll request all of you to pause at this moment and try this question yourself first, and then look at the explanation. So what is the question saying here? That sum of two natural numbers when added to their LCM results in 89. So how many such pairs of numbers are possible? So I'll take, let the numbers be A and B. Let the numbers be A and B. So it is saying sum of two numbers A plus B when added to their LCM. So LCM of A and B, it results in 89. So how many such A and B are possible? Number of pairs. This is what we have to find out. Now if you look at the options are not very big. 7, 6, 5 and 3 all in single digit numbers. So like we don't have to calculate too much based on the options. But again, we cannot go on hit and trial method, that okay, which are those two numbers when added to the LCM, because that would be quite cumbersome to comprehend and then to calculate as well. So that's a particular rule. So let us first get into the rule. The rule is like this, that if HCF of two numbers A and B is K, then A can be written as K into small a and B can be written as K into small b, where A and B are co-prime to each other. Two numbers are said to be co-prime if their HCF is 1. Co-prime means that is HCF of small a and small b are 1. Co-prime is basically a relation. Two numbers are said to be co-prime if their HCF is 1. Two or more numbers are co-prime if their HCF is 1. So if HCF of two numbers A and B is equal to K, then I can write A as K into small a and B as K into small b, where small a and small b are co-prime, and LCM of A and B can be written as K into small a into small b. For an example, let me take it in this way. Suppose I'll take two numbers 12 and 18. So their HCF is 6. So I can write 12 as 6 into 2 and 18 as 6 into 3, where this 2 and 3 are co-prime. Obviously they will be co-prime. Why? Because that's the definition of HCF. HCF means highest common factor. So whatever was the highest common, you would have already taken it out. So whatever is left, there is nothing common in it. That is why they are co-prime to each other. So 2 and 3 are co-prime to each other. And if you calculate the LCM here, is K. K in this case is 6. Small a is 2 and small b is 3. So 36 is the LCM of 12 and 18. Very simple rule, but very widely used in a lot of HCF and LCM questions. So we are going to use this rule in this particular explanation. How? Let us see. We got this equation A plus B plus LCM of A and B is 89. So let me use it here. A plus B plus LCM of A and B is 89. Now if let the HCF, let it be K. So I can write capital A as K into small a, capital B as K into small b, and LCM is K into small a into small b. This is equal to 89. I can take K as common, so A plus B plus AB. This is equal to 89. You see the LHS is expressed as a product. K into A plus B plus AB, it's a product. So RHS should also be expressed as a product, but 89 is a prime number. So the only way I can write it as a product is 1 into 89. This is the only possible way. And if I write it in this way, that means logically K has to be 1 and A plus B plus AB has to be 89. Now you can think the other way around. Why not K 89 and A plus B plus AB is 1? Now A plus B plus AB, it cannot be 1, because if you take A and B as minimum 1, so the value comes as 3. It cannot be 1. Okay, A plus B plus AB minimum to 3 आना चाहिए. So now if I solve this, okay, A plus B plus AB is equal to 89. I arrived at this. Now, beyond this point is what we are talking about, that I told in the beginning, problem solving approach. What we'll do here is we'll try and factorize this. How? You add a 1 on both sides, A plus B plus AB plus 1. So this side becomes 90. Now why would I add 1? A plus AB plus B plus 1. Rearrange the terms in this way. Now here if I take common A, B plus 1, you write it as 1 plus B. I just rearrange the terms, A plus AB and then 1 plus B. So here if I take A common, I get 1 plus B. And from the last two terms, if I take 1 common, I again get 1 plus B. And that is the reason I added 1. So that I can express this as a product. 1 plus A whole into 1 plus B, A plus 1 into B plus 1 is equal to 90. I could express it as a product. So now we arrived at a concrete result which will help us derive the values of small a and small b. Earlier it was open-ended, but by factorizing and expressing it as a product, we could arrive at some structure to think ahead and how to arrive at the values. We have some structure to think. How to proceed beyond this? So if I write a plus 1 into b plus 1 is equal to 90, I can clearly conclude that these two are factors of 90. So in how many ways can I write 90 as product of factors? So I can write it as 1 into 90. I can write it as 2 into 45. I can write it as 3 into 30. 4 is not a factor. I can write it as 5 into 18. I can write it as 6 into 15. 7 and 8 are not factors. I'll write it as 9 into 10, and that is it. Will not again repeat 10 into 9, 15 into 6. Will not write that way. So I got that, okay, I could write it as product of factors in 6 possible ways. Now if you solve this each way, suppose I'll write a plus 1 is equal to 1, which gives me small a is equal to 0, which also gives me capital A is equal to 0, because k is equal to 1 and capital A is k into small a and b is k into small b. To solve it here, we'll get small b is equal to 89, which gives me capital B is 89. But if a is 0, you don't have a number to begin with, so that is why this case is not possible. A 0 and B 89. A 0 means you don't have a number to begin with, so एक number का LCM we can't calculate. But if I take this case, so small a is 1, which gives me capital A is 1, and small b is 44, which gives me capital B is 44, and you can check, if you want to check, that sum of two numbers a plus b plus ab. So a is 1, b is 44, and LCM of 1 and 44 is 44, which results in 89. So this is satisfying, and accordingly all these values will satisfy on all these possible pairs. From each way you will get one pair except for the first one. So I had 6 possible ways, hence I'll have 5 possible pairs. The first case is not possible. and that is my answer. 5 possible pairs. From each of the ways, I'll get one pair each. 2 and 45 gave me one pair. Similarly, 3 and 30 will give me another pair. 5 and 18 will give me another pair. 6 and 15. We don't need to calculate individual A and B, because question is not asking what are the pairs, rather how many pairs. So we can see that, okay, out of 6 ways, only the first way is not possible. The remaining 5 ways will give us 5 pairs. Very good question and very beautiful question. And this rule is used. There are more questions concerning this rule. I'll take it up in the upcoming videos as well, so that all of you understand the application of this rule properly. But I hope all of you got an idea how to solve this question. So the answer to this is option 3, 5 possible ways or 5 possible pairs such that sum of the numbers plus their LCM results in 89. So that was it from my end for this video. Hope all of you liked the explanation and understood the answer to this question. If you have watched it this far, do subscribe to my Aptitude Club channel. I upload videos regularly, and do explore the previous videos that I have uploaded on this channel. It will definitely help you on your CAT preparation journey. We'll meet again very soon in yet another video. Till then, keep solving, keep studying, and thanks for watching the video. Bye bye.